So today I'm going to do my first video of what will probably be a series of at least 3 of mathematicians that appear in fiction. And today I'm going to do a mathematician which actually appears in a book and a movie, and that's Ian Malcolm from Jurassic Park. Of course, the book Jurassic Park came out in 1999, written by Michael Crichton, and the movie came out in 1993, directed by Steven Spielberg. And of course, everybody knows that character because of how well Jeff Goldblum plays him. Now, the physical description of Ian Malcolm from the book and the movie are very different, but I think the spirit of the character and the purpose of the character in each of the depictions, they serve the same purpose. Something that a lot of people complained about or were happy about, depending on how you viewed it, is in the book. Spoiler: Ian Malcolm dies. Now, of course, the Lost World, Ian Malcolm comes back, and I think that was basically, as Michael Crichton was, kind of pushed to do it because the character was so popular in the movie. So in the book, Ian Malcolm is what's referred to as a chaos theorist, or at least his concentration in mathematics is chaos theory. And I have notes here. I'm going to kind of look to the side and then kind of describe what chaos theory is a little bit. But through that lens of chaos theory, he is kind of the counterpoint of John Hammond. And John Hammond, the man who creates Jurassic Park, his hubris. His hubris is it's depicted in the movie, it's depicted in the book. In the book, he's more of a malevolent figure. In the movie, he's kind of a grandfatherly character, which his intention seem good, but he still has that hubris, thinking that he can bring back these animals from 65, 70, 80, 90 million years ago. And I say that because not all of the animals depicted in Jurassic Park would have lived at the same time, but he thinks that he can bring back these creatures back from millions of years, and there won't be problems. So what is chaos theory? Well, chaos theory, to say it started like with one single figure wouldn't be accurate, because just like most things in math and science, even though we will say a particular person did this thing, that's usually not the case. Even, for example, with calculus, we'll say, well, Newton and Leibniz developed calculus, but actually, to use a quote, they stood on the backs of giants. Same thing with Einstein. We say that Einstein developed the theory of relativity, and actually he has other people that he built upon their work. So, but we'll just say that chaos theory started with a guy named Edward Lawrence, who was an American mathematician who was modeling weather patterns. And he basically had this computer model, and he was putting in all this input, and he was trying to say, okay, let's see if we can predict the weather from this input. But what he observed is that if you made any small changes to the inputs, as the model went through time, or went through the time series, it would diverge from an outcome. So anyway, one small change could create this huge effect in the model, right? So introducing an element, if you have a model, introducing a single element can make the model, which would otherwise be predictive, it can bring chaos to the system. So the idea is that Ian Malcolm, he's brought in along with a paleobotanist and paleontologist, and he says, look, this park, there's all these factors, your hubris, there's all these things that you can't measure. This thing's going to go bad. And as I think he says, and I don't have the quote, he's like, look, all parks, or John Hammond says, all parks have problems with them. And then Ian Malcolm says, and I don't know if he says this in the book, but I read the book 30 years ago. Yeah, so I'm age 30 years ago, and I've seen the movie since then. I'll say that, or not so far back. But he says that when Pirates of the Caribbean breaks down, the pirates don't kill the visitors. So the reality of it is, and I like this character, but the reality of it is that this isn't two things with this. It's the problem here. It really isn't a result of chaos theory, right? So let's look at this. So Ian Malcolm looks at this through the lens of mathematics and says, well, this park, there's so many factors that it's going to fall apart, right? But we can assume that John Hammond probably actually had mathematicians, or at least math-minded people, with the design of this park. And the people I'm talking about would be in the fields of what's called industrial engineering, operations research, and system science. And I'm going to use these terms kind of, they overlap, they're not the same. But basically, when you're looking at the idea of industrial engineering, operations research, and system science, and maybe more so operations research and industrial engineering, is that they look at the components of a system that go into everything from running a business, running a factory, supply chain management, automation, and they optimize it. So industrial engineering is you have a factory, you want the factory to run as smoothly as possible, you want to reduce accidents, whatever. A field in operations research would be queuing theory, where you say, okay, well, how can we queuing theory? There's a mathematical field to this. So queuing theory is basically like, how can you design lines, and this is oversimplification of it, but how can you design a line where you maximize the efficiency? In other words, minimize the amount of time that people have to wait in the line. There's actually mathematical models for this. The problem with the models is this is where I have a critique in general, but one of the problems with the models work really great in the long run, as long as the system behaves a certain way and you know all the important inputs. Now, really, I think what went on with Jurassic Park is more along the lines of what a statistician slash investor finance guy, I guess you could call him, even a philosopher, Nassim Nicholas Taleb, said, and I believe it's in his book, The Black Swan, what he refers to as the ludic fallacy. And the ludic fallacy is basically, it comes from the Latin word for games, but it basically is like the misuse of games to model real life. So basically what it's doing is, and I'm going to kind of read directly from one of it, is saying, applying naive and simplified models in complex domains. So when can these things fall apart? Well, of course, there's three factors we can say that happens in the ludic fallacy. One is a result of chaos theory. It's small changes that affect the system. So you expect the system to behave a certain way. You may expect it to be a linear growth or a linear behavior or whatever. But these small little changes, they can affect it, and you can really diverge. The other thing is, it's impossible to have all the information. And that's what's happened with Jurassic Park, because the one thing they didn't take into account is that when they got the DNA from these, I believe they got them from frogs, they didn't realize that species of frog, because remember, and this is where the fiction comes in, they were able to get the DNA, extract the dinosaur DNA from amber from mosquitoes. There, of course, was DNA missing. Now, reality of it is that DNA will break down within thousands of years, not millions. So the very idea of this would be impossible, but for the purpose, it's science fiction. So they extracted DNA from the mosquitoes that are in amber, and there's DNA missing. So what they do is they fill it in with some of this frog DNA, and the frogs, the species, when there's only one sex, then some of I think they're all female, and some of the females will switch to male. So then the dinosaurs start breeding. They didn't have all they actually had that information, but the information would have been available, but they didn't have the information. So it was available, but when they were building this park, they didn't have all the information, if that makes sense. And the other thing is, you can't predict previously unobserved events, right? So when you're playing a game, you know what's going to happen, right? So if you roll a die, or a six-sided die, you know that it's going to land between 1 and 6. But when you're bringing back animals from 65, 75 million years ago, and you say, okay, we're going to build this fence, does anyone who has pets know that you can you have a new pet, you may put it in a cage, you may try to block it off. Like we have a cat, and we have like a kind of a fence that we want to keep our cat in a certain part of the house or out of a certain part of the house, and the cat can jump over. We never seen her do this before. Some people may say, of course your cat can do this. Okay, but the thing is that we hadn't observed that before, so we know that it's not effective. Well, for the people who are saying, of course the cat can do that, well, you've observed cats before. You haven't observed velociraptors and a T-Rex. So it's how this is going to behave. There's never been a park like this before. And the problem is that when this park breaks down, the animals eat people. So the is it a fact, or is it a matter of these small things affecting the system and it going off the rails chaotically? Yes, that's one of the factors that go with it, but it's I think it's more of the ludic fallacy. Now, albeit I think, of course, Nassim Nicholas Taleb's book, The Black Swan, where he talks about it, the ludic fallacy, came out. Um, I think it came out around maybe 2007. So it came out at least, or about a half, maybe 2007, 2000. Yeah, I think 2007. But anyway, the point is, it came out a quarter of a decade after Jurassic Park. So even with that, I think applying chaos theory is it's a pretty cool explanation. And one of the things I do like about the book is that as you go from each chapter, there are these each chapter starts with a fractal, and a fractal is this pattern, this physical geometric pattern that it increases, it gets bigger and bigger, but it follows a pattern. But the thing about it is that as it gets bigger and bigger, how it's going to look, even though it is a pattern, it's an observable pattern. As it gets bigger, it's kind of hard to see what it's going to look like 20, 30, 40 iterations after after the initial pattern. So, but anyway, overall, I think it's a great depiction of mathematics and science and science fiction. It's a great depiction of mathematics in the movie. You could argue, or not even really argue, you could say that the explanation of chaos theory that's presented in the movie isn't quite accurate. But I mean, look, he's flirting with Laura Dern. So I mean, look, I don't think it really matters. You're trying to flirt with Laura Dern. She seemed to be feeling it, so it served its purpose then. All right, but I do think, and I guess I'll conclude with this. I think that the movie is or the movie in the book, not only is it a critique of the hubris of thinking you can control nature, which is the theme of the movie, but I think it speaks of those people who believe that they can create models. And we don't see those people, but we can assume that when they were constructing this park, there were industrial engineers, there were system scientists, there were operations researchers, those type of people, and they probably said, "Look, this is how you can make this park efficient. This is how you can make it safe." And those models you build, they're not going to always work, and we see this. We see this when we have models of the economy. One of the things about economics that's occurred over the years is we've got more computing power. We have economists who think that they can predict the effects of lowering and increasing interest rates. That's a hubris there, saying that you can predict the economy, that you can do these things, that you can measure all the factors. Now, I will really, really conclude with this, is that I am definitely not against models, and I do think a lot of people, when they're critical of models, they're using this for less than honest reasons. For example, I know that there are people who are critical of climate models. Well, the thing about a climate model, and we know that, as I said, Edward Lawrence came up with chaos theory when he was modeling weather. Weather and climate are two different things, but what we can say is that, yes, tweak a few variables and you'll get a different result. But what we do with climate models is that we measure a trend over 100 years, and we do observe that as we put carbon into the atmosphere, it causes heating. Now, the details may be different. What areas will get more rain, what areas will get less rain, what areas will be hotter, what areas will be colder, that's not exact. That's where we get that's where the chaos element is introduced. But what we do know when it comes to climate as we put carbon emissions into the atmosphere, the world is becoming less and less, let's say, secure, and in many places less and less habitable, just for different reasons. Some places are becoming less habitable because there's more storms, hurricanes. Some places are becoming drier. Some places are becoming wetter. Some places are getting more fire. So, although I am critical of models, I am not going to sit here and say that models don't serve a purpose. And even though the details may be affected by chaos theory, the big picture still holds in many cases. Anyway, So that was me wanting to kind of talk about Jurassic Park, the mathematics in Jurassic Park. I didn't really talk about Ian Malcolm that much because there's tons of videos talking about Ian Malcolm. He's a cool character. He's a cool character in the book. He's a cool character in the movie. It's Jeff Goldblum. So of course, um, and maybe I don't know when I decided to study mathematics, I'm sure that character was probably one thing that was floating in my head that probably drew me to that field. But anyway, thank you.